Okay, so our last section for this week, we're going to look at 1.2, part of 1.3. And we're going to go over a lot of stuff you can do with the graphing calculator. Okay, some things I haven't shown you yet. So in order to have some different things to go over, we're going to go through a few problems, and I'll show you how to solve them algebraically. And then I'll also show you how to do the same problem on the calculator. Okay, but as we go through the problems, the book kind of gives us some suggestions about how you should go about solving a problem. Okay, so this applies to any kind of problem you need to solve, not just a math problem. The first thing you want to do is read through the problem and determine two things. Okay, what are they telling me in the problem? What information are they giving me? And what are they asking me to figure out? Okay, no matter what kind of problem you're trying to solve, if you can't figure out what somebody's telling you to help you solve the problem and what they're asking you to find, you're not going to be able to solve it. Okay, so once you've got all the information from the problem, okay, you figured out what they're giving you, you know what they want you to find, then we got to figure out a way to solve the problem. Okay, so in math, can anybody think of different approaches that we might use to solve a problem? Any strategies or techniques? In fact, we did some when we went over the homework. I used a certain approach to solve that distance problem where they gave me an x. What did I set up? Yeah?
A formula?
Yeah, I set up a formula or set up an equation. Okay, so that's one approach. Okay, set up an equation. How about if somebody gave you a word problem and they described a whole scene to you? What might be a good thing to do if somebody gives you a verbal description of something so you can visualize it better?
You can draw it out.
Yeah, you can draw it out, make a picture. Okay, sometimes making a list is a good approach. For example, if I said to you, tell me all the different ways you can arrange the letters A, B, C. I'm asking you for all the ways, so you make a list. ABC, BCA, CAB, and so on. Now, the only problem with a list is that if you have a lot of different possibilities, making a list can be time-consuming. Okay? So making a list might also involve using a computer to generate things for you. Okay, so then after we decide on what approach we're going to take to solve the problem, then we actually go ahead and solve it. Okay, and sometimes you might pick a plan and think, you know what, this is going to be a good way to solve the problem, and it doesn't work out. So you might have to go back and try something else. Okay, so for me, when I solved that distance problem, the first thing that popped into my head was make an equation. I know the distance formula. I can plug things in, and then maybe I can figure out how to get a variable by itself. Maybe somebody else made a picture. Okay, maybe you actually draw the coordinate and figure out, well, what's the point that's 10 units away, looking at a grid. Or maybe you just take a guess and you got it right. So, okay, so there are different approaches that can work on the same problem. All right, so this one, they're telling me the approach they want me to take. Okay, they want me to write an equation to model the situation. And for this situation, it costs $15 to rent a car, and it costs 20 cents for every mile you drive. Okay, now usually when you set up an equation, you've got things in it besides numbers. Okay, what am I thinking of here?
Words.
Okay, I guess you could have a word in an equation. Even simpler, what makes up words? Letters, variables. All right, so I'm thinking here, I'm probably going to need at least one or two variables. Anybody think what I might need a variable to represent in this situation? Denver?
Miles.
Yep, I need a variable to represent how many miles I drive. And what is that going to affect? Number of miles that I drive will change what? And this is another variable.
The
Yep.
amount of money company charges.
Yeah, it's going to change the cost to rent a car. Okay, so I'm going to let y be my cost, and I'm going to let x be the number of miles that you drive. Now, I definitely don't want to switch x and y, okay, because we're going to learn in the next section, x and y have certain names. Okay? X is called your independent variable, and y is called your dependent. Okay? And the way I figure out which one is which is I read it to myself and I see which one makes more sense. I say, does the number of miles I drive depend on the cost? Or does the cost depend on how many miles I drive? It's the second way. The cost is dependent on something. In this case, the miles you drive. Okay, so cost is dependent, miles is independent. You drive however many miles you want, and then they'll give you the cost. All right. So anybody think they can give me an equation starting out like that would tell me the cost to rent this car? Luke?
15
Okay.
plus 0.2 times x.
Yeah, exactly. Okay, I'm just going to write it in a little different order, but I'm going to do exactly the same thing you just said. 0.2x plus 15. All right, so that's a formula. You tell me how many miles you drive. I can plug it in, and then I can find the cost. Okay, so the point here wasn't to give you a really hard problem to solve. I wanted to try to give you one that was pretty straightforward. Now we're going to do some stuff on the graphing calculator with this. And some algebra. But any questions on that equation? All right. So I want to use that model to figure out the cost for driving a certain distance. Okay, let's start with 50 miles. Okay, Adrian, where would I plug in 50? For x or for y?
For x.
Yeah, because miles is x. We said that earlier. So I'm going to fill in 50 for x and see what the cost is. So I've got 0.20 times 50 plus 15. And that's going to give me a cost of how much, Luke? $25. Okay. Yeah, it's pretty cheap. How about 100 miles? Since it's double the distance, it's double the cost, right?
Not necessarily.
Not necessarily. How come?
Because the 15 is a constant.
Right, we're going to be careful because this $25 includes an amount that shouldn't be doubled, the 15. That's a one-time fee. Okay?
That'd be 35.
Yeah, so the only thing that's going to double is the cost from the miles that you drive. Not the cost, not the 15. Okay, so it's 0.2 times 100 plus 15, or as somebody just said, $35. Okay. Any questions on that? All right. So that equation that we came up with, okay, that's called an algebraic representation. So if in the homework you ever see directions that say find an algebraic representation, basically it means come up with an equation. And when you're looking at an algebraic representation, it takes the word problem out of it. If you gave this formula to somebody, they would have no idea this is about a rental car. They charge us 20 cents a mile and $15 fee to rent the car. Okay? It's just an equation. All right, so second example, using the same formula we had in example 1. It says, suppose Sarah was charged $50 for renting the car. How many miles did she drive? What's a little different about this example?
You're given the total cost, but you're not given the amount of miles.
Right, this time we're given the dependent variable. Okay, we're given the cost, and we're going to work backwards to find the independent variable. We're going to find x. Okay, and this one we're going to do two different ways. Okay, the first way I'll show you how to do it is algebraically, and then the second way I'll show you how to do it is on the calculator. All right, so doing it algebraically, what letter does 50 get plugged in for? Y. So I'm going to fill in 50 equals 0.20x plus 15. Okay, and Hannah, what would be my first step to solve that equation?
You want to subtract the 15.
So subtract the 15, and 50 minus 15 is going to give me how much?
35.
Yeah, good job, 35. And my last step, Bria, to get x by itself? Yep, divide by 0.20. If you have 0.2, that's the same thing. So dividing by 0.20, 0.20 is a fifth. So dividing by a fifth is the same as multiplying 35 times 5. So I should get 175. Anybody check that on their calculator? Is that what you got?
Yeah.
Okay. And that's $175 or miles? Miles. Right, so that's the algebraic approach to solve it. Okay, now we're going to take a look at how we do it graphically. Okay, and for this, I'm not going to write down every step. I'm going to show you. And when I'm done, I'll put a picture of what we do in the notes. All right, so I'm going to bring up my calculator. I'm going to turn it on. And I'm going to just reset the window. I'm going to start with a standard window. So I'm going to just do zoom 6. Okay, put everything back the way it was. And I'm going to go to y equals. If you've got anything typed in there, you can just clear it. All right, so now I'm going to focus on this line right here. I have something on the left, and I had something else on the right, okay, before I crossed out the 15. Okay, I'm going to take what's on the left, and I'm going to type that in y1. Okay, so I'm going to type in 50. Okay, I'm going to take what's on the right in green, and I'm going to type that in y2. 0.20x plus 15. Okay, so to get an x, in case I haven't shown you that, you press the button right below mode. 0.2x, that's the same thing as 0.20. It's 0.2x plus 15. And I'm going to hit graph, okay, after typing that in. Okay, what I'll do is I'll put a copy of this page in the notes so you can see that. Okay, as long as the little yellow circle's going in the upper right, it means it's doing something. Let's wait and see what happens. And I have nothing on the screen. How come? What's wrong here? There should be something on the screen. I typed something in. Yeah?
Our window isn't high enough.
Yeah, the window isn't high enough. Okay, just from that first equation alone, okay, y equals 50. Does anybody remember what kind of line that is when you just have y equals a number? Yep, Nick?
Horizontal.
Exactly. It's a horizontal line. In this case, it's a horizontal line up at 50. So I got to set my y max to at least 50. In fact, because I don't want the line right on the edge of the screen, I'm going to go a little past 50. Just put it at 60. Otherwise, the line's right on the edge of the screen. Now, because I already solved this problem, I already know how high x has to go. 175. Okay, normally, I don't know that. Okay, so this is the tricky part. Trying to figure out a window that fits what you need to see on the screen. All right, so let me I'm going to set x max at 100. Now, I know that's not going to work, but if you didn't know the answer to the problem, you might not know that it's not going to work. Okay, so I'm going to hit graph and just show you what happens. Here's my horizontal line at 50. Here's my other line. And I can see, well, they're going to cross somewhere, but I can't see it yet. Okay, so I might say, all right, I'll try to set my x max higher. So I'm going to try 200. And now I know 200 is going to work because I already know the answer to the problem. Now, we're not using algebra this time. We're using a graphical approach. So what do you think I want to know about the blue line and the red line? I want to know where they're equal, but what does that mean visually? Where they do what?
They intersect each other.
Yeah, where they intersect. Okay, and the calculator can do that for me automatically. Okay, to do an intersection, you press second, and then the button that says trace. Okay, when you do that, it brings you to the calculate menu. You have a few different options. 6 and 7 are calculus. We won't use those all year, but we'll use 3, 4, and 5 quite a bit. Which one there do you think is going to tell me where they cross?
5.
Yeah, 5. So just press 5. Okay, and now it's going to ask me 3 questions. You could have multiple lines on the screen. Okay, let's say you had a green line on the screen too. There'd be all kinds of intersections. You have to tell the calculator what 2 lines do you want to find the intersection for. Well, we only have 2. Okay, so there's not really much to pick here. But I want the blue line, so I'm just going to hit enter. I want the red line, so I'm going to hit enter. And then it asks me for a guess. Okay, the guess is only important, really, if you have multiple intersections on the screen. Let's say you had a parabola with a line coming through it. If you put the guess closer to this point, it'll give you this intersection. If you put the guess closer to this point, it'll give you that one. So wherever you put the guess closer to, that's the intersection point it gives you, because it only can do one at a time. Since there's only one on the screen, it doesn't even really matter how close I get to it with the guess. That's the only intersection point. It's going to find it automatically. Okay, so it tells me that these lines cross when x is 175 and y is 50. Okay, so there's your answer right there. That's the number of miles. Okay, and even the way I just did it on the calculator, there's other ways to do it besides that way, using a calculator. But for now, that's the way I'll show you. Okay, any questions on that? Is anybody unable to get that intersection to work? It didn't work?
Oh, no. I thought you said.
Oh, you're good, okay.
2 way.
Anybody that was not able to get it to work? All right. What's nice about this approach is we can use it when we have equations that we can't solve algebraically. Okay, there are equations that cannot be solved with algebra. We can solve them with other methods. One of them is a graphing approach. So that's why it kind of comes in handy. Okay, so when we graph something or do anything on the calculator, you've got to have a window that lets you see all the important stuff. Important stuff, that's things like, where does it cross the x-axis? Where does it cross the y-axis? If it's a parabola, where's the minimum or where's the maximum? If you're graphing multiple lines on the screen, maybe we want to see, do they cross somewhere? Okay, that's important. If you're trying to find an intersection between 2 curves or lines, doesn't matter, two graphs, and the intersection point is off the screen, the calculator will not find it. Okay, you've got to get the intersection point on the screen for it to find it. Now, if you have a newer calculator or a different brand, maybe it does things a little differently, but in general, you've got to have the intersection point on the screen if you want to find it. Okay, having a window that shows you everything that's important, that's called a complete graph. Okay, so in the homework, when you see directions that say find a complete graph of the following, there's nothing to write down other than the window that you used. All I need to know is your x-min, your x-max, your y-min, and your y-max. Just write down your window. Okay, and the way I'll test you on it tomorrow is I'll give you some kind of function. I might even give you a function that's a shape you've never seen before. That doesn't really matter. And I just ask you to find a window where I can see all the important stuff. Okay, now this one is probably a graph people have seen before. Does anybody know what shape that is when you square something? It's not a line.
Parabola.
It's a parabola. Okay, kind of a hint, and we're going to get to this in a little, later sections. That number right there tells me how many times the graph, well, it's actually one less than that. If you subtract 1 from that number, it tells me how many times the graph can turn. Okay, a parabola can make one turn. So it either basically looks like that, or it looks something like that. If I had cubed here, if I put a 3, then I could have a graph that takes 2 turns. So it could be going up, it could turn down, and then it could turn back up. Okay, if I put a 5 here, the graph could take up to 4 turns. So knowing how many turns a graph is going to take gives me a hint if there might be something off the screen I need to see. Okay? And notice I said could take. Just because it has a 5 here, it doesn't guarantee it's going to take 4 turns. It could. Yeah.
I was going to ask that.
Yeah, no, it doesn't guarantee it. It could. All right, so we know that this is going to be a parabola, and it's been shifted up 10. So knowing what we know about the standard window, is the standard window going to work for this problem? Nope. The standard window only goes up to 10. Okay, I think negative to 10 to 10 on the x-axis should be fine. Okay, so there's your standard window. But what value should I change here so I can see the parabola? Yep, John?
Y max,
Yeah, y max. And what do you think a good value would be?
25.
Yeah, 20. There might be multiple answers here. I'd say 20 would probably work. 25 will work. Nothing very interesting is going to happen if you keep setting the y max higher.
What did you find for the X-Men?
X-min and x-max, just your standard window, negative 10 to 10.
Oh, what was the y equals?
X squared.
X squared plus 10. Okay, a value that I would say would not be good for y max, I wouldn't type something in like 500. It's going to make the parabola look very skinny. In fact, you might not even be able, actually, it stretches it out. So to me, that's kind of a distorted picture of what it should look like. And if you go even bigger, the parabola is going to get flatter and flatter and flatter. So you're kind of distorting what it really looks like. Okay, so 20, 30, 40, any values like that, I think that's reasonable. That's what it should look like.
It says that I taken an error.
You have an error? Let's take a look. Yeah, so when you type it in, just make sure you don't actually have an extra symbol. It should just be the x squared and just a plus sign and just a 10. Okay, so the directions say find a complete graph. All I need you to do is write down that window. And all you really need is x min, x max, y min, y max. Okay, so that shape we just graphed, again, that was a parabola.
What are the y max scales?
That's the tick marks.
Oh.
Yep. I don't really care about the tick marks. Okay, so in general, you might see parabolas written like this, ax squared plus bx plus c. Okay, a lot of times when you do factoring or quadratic equation, That's how it's written. Okay, the A, the B, and the C all have different effects on how it changes the parabola. It might move it up, might move it left, might stretch it out. Okay, we're going to study eventually, visually, how changing A, B, and C affects your picture. All right, let's find a complete graph for square root of x plus 20. Now, before we graph it, what do we know when we try to take the square root of something? What kind of number do you have to take the square root of? If we're dealing with reals, okay? Forget about imaginary. If you're not sure what kind of numbers you can take the square root of, think of what numbers you are not allowed to take the square root of.
Negatives.
Negatives. Yep. So you can take the square root of any number that's not negative. That includes 0 and up. So there are certain values here for x I am not allowed to use. Like negative 100 plus 20, that's negative 80. That's negative. I can't use it. Can anybody think or describe to me what values of x I can use here?
0 and up.
Okay, I agree. I can use 0 and up. I even think I can use some negatives, like negative 1 plus 20. That's 19. So negative 1 would be okay. I can even go a little more.
Negative 20.
Negative 20. Yep,
Greater than or equal to negative 20?
and up. Yeah. So I can use any x value that's greater than or equal to negative 20. Right? Let's do our graph and see what we got. Okay, so square root, I have to press second x squared button. Now, if you started out with a standard window, it's not going to look very good. It almost looks like a line. Square root functions are not lines. Okay, that's not a good picture, not a complete window. Okay, John told us that the smallest x value we can use is negative 20. So let's go see what's happening down towards negative 20. And because I don't like a graph right on the edge of the screen, what would be a good value for x min?
Negative 30.
Yeah, negative 30, negative 25. Those would be fine. Now we can definitely see it's not a line. That's how a square root function looks. It's a curve. It does look like it kind of flattens out, but it really never does. It's always curved just a little bit. Okay, so find a complete window. That's it. We're done. That's all I want you to do.
And so, like, if you ask that, just for the answer, we write the x min, x max stuff.
Yep. I would like you to write down those two
Yeah.
and those two.
So when you're asking for finding a complete graph, that's all you have to do right now is the x min, x max, y min, y max, right?
Yep. And if you want to write it like this, you could. Negative 30, 10. Those are my x values. And my y values, negative 10 to 10. I think we've seen this in the book.
So you want them like that?
You can write it like this, or you can write x min equals, x max equals, y min equals, y max equals. Either way, whichever way you want. Just don't do anything other than those two ways. You'll confuse me. Okay. Any other questions on that? All right, so that finishes up section 1.2. I don't think we're not going to finish 1.3 today, so we'll just we'll do what we can, and then we'll stop, and we'll pick it up next academic week. All right, so section 1.3 talks specifically about functions. Okay, functions are a special kind of graph. Some lines are functions. A circle is not a function. Square roots, if you graph just the top half, just the positive part, because remember I said square roots have two answers. If you graph just the top part, that's a function. Okay, if I graph something like this, don't worry what I just typed in, I just basically wanted to flip that over. That picture is not a function. Does anybody remember visually there's a test to figure out if something is a function? It's 3 words. Yep, Ian?
If one value corresponds to multiple x values, then it is not a function. Now, it's a
Closed.
one x values, multiple y values, it's a function.
Right. If you can pick an x value and you have multiple y values, like let x be 0, what's y? Well, it looks like it's up a little above 4, and it looks like it's a little below -4. I have 2 choices. Okay. Another way to visualize that, it's called the vertical line test. If I can draw a vertical line and it hits it in more than one spot, that picture is not a function. Okay. And I'll write that down in a little bit. Our example from 1.2 with that rent-a-car, that was a function. Okay. It's just a diagonal line. Did anybody remember the name I gave to x and y? X was the something variable and y was something variable? Yep.
Y was the dependent variable and X was the independent variable.
Yeah, y was the dependent, x was the independent. Okay, a few different names for x and y. You could look at it as input and output. In other words, you plug in a value for x, do the arithmetic, and you will produce an answer for y. That's the output. You tell me miles, I'll tell you cost. I'm outputting the cost to you. Another term we might see, x is called the domain, and y is called the range. Now, domain basically means the numbers that make sense to plug in for x. Can anybody think of numbers that would not make sense to plug in for x in the driving car situation? Yep.
Like negative 10 would work.
Right.
You can't drive 100 miles.
Yeah, any negative number wouldn't work. So if I ask you, and I will, to describe the domain of a function, I want to know the values that make sense. Okay? In a word problem, negatives a lot of times don't make sense. If you're talking about like time or distance, no such thing as negative time, negative distance. Okay, so the x is the domain. Those are the values you plug in for x. Y are the answers that you get out. Okay, so in this formula, you would never get a cost below what number?
15.
You'd never get a cost below $15. Even if you drive 0 miles. If you just rent the car and don't drive it, you just keep it. You still have to pay $15 just to sign the car, take the car for the day or whatever. Okay? So the range here would only be numbers that are $15 and up. Okay, and even that, we might have to be a little more specific because I don't think it would ever be possible to pay $15.01. You'd never be charged $15.01. You're only charged in 20-cent increments. So you could pay $15. You could pay $15.20 if you drive a mile. You could pay $15.40 if you drive 2 miles. But you're not going to pay $15.23. Okay, that's not in the range. Okay, so the range, those are the kinds of y values that you get. Okay, and now I'm going to describe a function exactly the way Ian just did. So a function is an equation where every x value has one y value. A different way to say it is every input has one output. Every value in the domain has exactly one value in the range. All those things I just said mean exactly the same thing. Okay, this, I think I already explained to you guys domain and range pretty sufficiently, but if you need to write it down again, domain is the numbers you're allowed to plug in. Range is the type of answers you will get out, answers that you get for y. Yeah, unless a problem states otherwise, the domain always has to be a real number. So in other words, I want you to forget about imaginaries for now. So there are certain operations in math we can do that give us answers that are not real numbers. Okay, square root is one of them. Anytime you deal with square roots, you've got to be careful. You are not allowed to take the square root of a negative. So you need to think about that when I ask you for domain. Okay, there's something else we're not allowed to do with division. Okay, what are you not allowed to do with division, ever? Yeah, you can't divide by 0. So if I gave you an equation like this, and I said to you, I want to know every number that I'm allowed to plug in for x. Well, you can basically plug in whatever you want. There's only one thing you're not allowed to do with division, and that's divide by 0. So what is the only number I could not use for x? 5. Okay? So the way I would describe the domain here is I would say all numbers except 5. Okay? You can divide by positives, you can divide by negatives, fractions, decimals. You just can't divide by 0. And the only time that would happen is if you let x equal 5. Okay? Any question on that idea? Okay, when we write functions, there's two different ways you can do it. The first way is the way we have been doing it, y equals notation. The second one has this f parentheses x. That's not how you say it. Does anybody know how you say f parentheses x? Yep. Yeah. F of x. Okay, f of x is just a different notation for a function. If you don't like seeing f of x, you can always just replace it with a 1. Any questions on those two different notations for a function? Okay, and you don't always have to use the letter f. You might see g of x, h of x. Okay, you can use any letter that you want. Okay, so first example is pretty similar to what we've been doing, finding a complete graph, but I also want to know the domain and the range. Anybody have what's on the left? Okay. So I'm going to just change this to square root x minus 3. And what values make sense for x here? Remember, you can't take the square root of a negative. So I'd have to pick values for x that would never end up causing a negative here. So don't pick like 1. 1 is not a good value for x. It should not be in the domain. It's only certain numbers enough. Yep, Adrian?
4.
Okay, what about 3.5?
Oh,
That would work. 3.5 would work. So how could we describe the values that work? Nick?
Where is it supposed to be?
How about 3 itself? So if I plug in 3, I get 3 minus 3. That gives me 0. Is that negative? Nope. So 3 is actually okay. So the domain is going to be all numbers that are greater than or equal to 3. And there's two ways to write it. That's writing it as an inequality. Or you can write it like this. Bracket is kind of like the closed circle, filled in circle. That means including that number. So I can put a bracket, and this means my lowest value is 3, including 3, and the highest value I can pick is infinity. You never put a bracket on infinity because you can't reach it. It's not a number. So we always put a parenthesis on infinity. So these mean exactly the same thing. All right, so let me graph that. Since I can pick numbers that are 3 and up, I'm going to go from 0 and up, just so my graph's not on the edge of the screen. There's my graph. Now, what am I going to get for the range? Those are the y values. What kind of y values are in that picture? Not all of them, because this graph doesn't go up and down forever. It's only really going in one direction on the y values. Yep, Denver?
Greater than or equal to 0.
Yeah. For the range, you're never going to get numbers that are negative. You're only going to get numbers from 0, including 0, and up. I'm going to skip 2a. Let's do 2b, just because it involves typing in an absolute value, and that's something worth showing you. I might have already shown you. Okay, so I want to type in the absolute value of x squared minus 4. Did I show yesterday where absolute value is? No? Okay, so you go to math, go over to number, and it's the first option. It says ABS. Okay, so if you hit that, puts in your absolute value bars.
What band do you have?
Math, go over to number, and then it's the first option. And I'm going to type in what's inside those bars. X squared minus 4. Okay, I always like to start out with a standard window, just kind of see how that works. So I'm going to do zoom 6. And there's my graph. It kind of wants to be a parabola that's been shifted down 4 units. The problem is the absolute value won't let it do the negative part that should be right here. So what it does to that negative part is it flips it up and makes it positive. If I took out the absolute value, it would go down just like that. It would flip that part down. Okay, what's my domain here? What numbers are you allowed to square? Any of them. You can square any number you want and subtract 4. Remember, I said the things to look out for are dividing by 0 and square roots. Neither one of those conditions can ever happen here. Okay? So the domain, you could write all real numbers, or you can just write that. It goes from negative infinity all the way to positive infinity. Don't ever use brackets on infinity. Okay. What about my range? Does that graph go up and down forever? Goes up forever. And yeah, and the lowest that it hits is 0. So it hits 0, and it goes up forever. If you weren't sure what this lowest value is, the calculator has another function under calculate, same place you did intersect, called minimum. And under minimum, it can tell you what is the lowest point. Okay? And the way it works after you go to minimum, put your cursor somewhere to the left of where you think the minimum is. Hit enter, and it'll put in a dotted line. Okay? Then put your cursor somewhere to the right where you think the minimum is. And now you've just told the calculator, I want you to look between those 2 lines for a minimum. The guess, just put the guess as close as you can. Okay, and it tells me that when x is basically 2, remember it's a calculator, it can't do exact answers sometimes, but it basically should say when x is 2, the y value is 1.3 times 10 to the negative 6. In other words, 0.00000013. So if there's that many zeros, it should just be 0. Okay? So when x is 2, y is 0. Okay? And that's the same thing here. Okay, lowest y value is 0. Any question on the domain and range for 2b? Right, so sometimes they ask us to evaluate a function. All that evaluate means is to plug in what they give you and simplify. Yeah, go ahead. Yeah, I'll put it up. Yeah, it'll be up online. Okay, so if you ever see the directions that say evaluate, just plug in a number and simplify. Okay, I'll go through just a couple. So if they put f parentheses -2, that means f of -2. Just fill -2 in for x, that's it. And add 1. And what would you get if you do that out? Yeah.
5.
Yeah, you get 5. That's it. That's all they're asking for. Okay, if they ask you to plug in 3, 3 squared plus 1 gives me how much? 10. Yep.
Did you go?
Mhm. If they ask me to plug in a, what would I get there?
A squared plus 1.
Yeah, a squared plus 1. There's not really anything you can do. You just plug that in. And if they ask me to plug in something like x minus 3, now from what I learned in Algebra 1, I need to FOIL that out. Okay, so I'd get x squared minus 6x plus 10. Okay, some people call it distributive, some people call it FOIL. Right, and the last thing, I already told you earlier that not everything is a function. Okay, there's a certain test that we use to determine if something is a function, and that's called the vertical line test. Okay, so all you really need to know on this last page is what the vertical line test is. Okay, vertical line test just says if you've got a picture and you draw a vertical line and it hits the graph in more than one spot, you don't have a function. Okay, that's the vertical line test. So would a circle be a function? No, it would hit it more than once. How about a parabola?
Yeah.
Yeah,
Actually, yeah.
just a basic parabola. A vertical line would never hit that more than once. Remember, the sides of the parabola never really are vertical. They're still angled. How about this? It's called a sine wave or cosine wave. That's a function. A horizontal line would hit it more than once, but that's something else. Okay. So that's your vertical line test. And that's it. Right, so the first part of the homework, that's on a lot of graphing and finding intersects and things like that. So that's page 20. Okay, 6 to 10. 18, 21, 29, 32, 38. And then the last part is what we did in section 1.3. Okay, talking about functions and f of x notation. Okay, that's numbers 3 through 8, 11, 13, 16 through 19, and 24. Okay, so don't forget, I won't be after school today because of back to school night. And don't forget also, if you sign up for the website, you get 5 points on our test tomorrow. Test tomorrow just covers what we did Wednesday and Thursday.